Hello, and welcome to this Get IAM Right Insight Series webcast. Today's topic is securing the solutions that protect your privileged accounts. My name is Kelly Hardy, and I'm the Product Marketing Manager for One Identity's Privilege Management Solutions, and your host for today's call. I also have Tyler Reese on the line, Product Manager for One Identity's PAM Solutions. Today, Tyler is going to walk us through some of the security challenges organizations face when implementing PAM solutions and how our newest solution, One Identity Safeguard, helps solve those challenges. And with that, I will turn it over to Tyler.
Thank you, Kelly. Welcome, everyone. I wanted to go ahead and walk through some of the challenges that we see customers having as they are trying to secure the solutions that protect their privilege accounts and privilege sessions, and also talk about how our newest product, Safeguard, can be able to help organizations with those problems. So this concept of being able to secure the access that gives you access to other identity stores or privilege account stores or whatnot is not a new concept, and it's actually been gaining a lot of steam as of late. I want to share a couple of examples of how organizations, some of the largest organizations, are advising their customers to also do very similar things that we're doing. And then we will talk about how the securing of our solution goes one step above those. One of the first things that we are seeing is with what Microsoft is advising their customers, specifically around privilege access workstations. For those that are not aware of what a privilege access workstation is, a privilege access workstation, or what sometimes is shortened as PAWS, is a workstation that Microsoft advises their customers to use whenever they're accessing Active Directory with any privilege account, such as a domain admin, schema admin, enterprise admin, etc. The reason for this is because of the increased attacks against Active Directory through attacks such as pass the hash and golden ticket and skeleton key. There needs to be a way of making sure that those hashes cannot be taken by attackers and be replayed against Active Directory. So Microsoft has given a directive that any privilege access to Active Directory should be done through privilege account or privilege access workstations. And to build a privilege access workstation, there's many steps involved, starting from making sure that you download Windows from a trusted source and compare the hashes, to running the baseline security management, all the way through basic ideas of being able to make sure that you don't run unapproved signed programs and so on and so forth. And again, the idea of this is being able to stop attackers from underneath the covers stealing any credentials or any data from the admin that's actually trying to perform their job. And Microsoft actually discusses this in more detail when they talk about how they manage the Azure Active Directory infrastructure that has literally millions, if not billions, of accounts. One of the guidelines that they mention is using a privilege account workstation, that their admins use a privilege account workstation when they access the infrastructure that manages Azure Active Directory. They also do things such as privilege account management and a lot of the other techniques that we see today. But we wanted to call this out as an important part because if an attacker has the ability to infect the workstation, then they're able to get access to either tens of credentials or even up to billions of credentials in the case of Azure Active Directory. And finally, one last example of being able to secure the solution or secure access when accessing your most privileged accounts is when Amazon recommends using jump hosts to be able to have a sane way to access your AWS workloads, such as your Linux and Windows machines. Again, they recommend some of the same tactics to be able to lock down a lot of the functions the OS can do so that malware or other software that could potentially steal credentials or plant Trojans on your jump host are disabled so that you can access those hosts without them being susceptible. So how does this translate to access for your PAM solution? Many PAM solutions that are out on the market today have the ability or require the customer to have to install the application, the operating system, so on and so forth. Some of them even have virtual appliances that they pre-package to be able to be packaged as a virtual container. Now, while this is convenient to the customer or allows for a varying ways of deployment, this could be fraught with peril when we discuss the ability or discuss reasons that that could be attacked, and a company's most sensitive credentials could be spilled out on the internet. And so we have developed a solution, the One Identity Safeguard solution, that is delivered as a secure hardened appliance so that customers are able to sleep well at night knowing that all of their privileged accounts and sessions are being secured in a hardened appliance that can be that can be protected from not only physical attacks but also attacks to the OS and application level. And we'd like to go over a couple of those tactics that we use so that we can show the varying levels of security that we use to create a defense in-depth posture for Safeguard. So going from the bottom up, let's first briefly discuss what we do on the hardware. First of all, the software and the applications are pre-installed so that the customer is not required to be able to harden the OS or be able to make any changes to the application or need to make changes to the application to make sure it's hardened. We've removed all console access and the BIOS is pre-hardened or pre-secured so that there can be no other applications that are installed on the appliance. And we use hard drive encryption and the TPM for key storage so that all the keys and the data at rest are protected. When we move a level up to the operating system and to the actual Safeguard application, One Identity takes care of all of the patching and the removal of unnecessary services on the appliance so that nothing is running that shouldn't be running. We also install several firewalls to protect access to and from not only Safeguard, but the internal processes that are running as they talk to each other. And finally, in the actual Safeguard application itself, we do things such as secure backups that are already encrypted with encryption keys that are on the appliance, and also using encryption for column level encryption for things such as passwords and other sensitive data on the actual host. Let's go ahead and double click on let's first discuss, compare that to what installable software is, and then we'll go ahead and double click on some of the features that we're doing in the hardening to give you a little bit better idea on how we're doing that. So when we compare a hardened appliance to installable software, a lot of the risk and effort is now shifted to the customer to be able to maintain. So for things such as hard drive encryption and securing of keys, if that can be done with the capabilities that the software has, that requires the end administrator to perform that and continually attest that it's being encrypted. Also, the software needs to be installed and hardened. Patches need to be checked on constantly, and services need to be disabled to make sure that you can have the same security posture. And we'll briefly talk about in the next section some of the hardening that occurs. But one thing to keep in mind for those that have to harden their own solutions is that when patches are added by the operating system in the application, sometimes that creates an unhardening of the appliance, which causes the hardening process to reoccur or needs to be extended when new features are added because of new features that the operating system patch or application could have added. So let's talk a bit about the physical security of Safeguard and some of the things that we've done to make sure that we're able to protect the physical appliance. First of all, the Safeguard appliance is a custom-built chassis which is compliant with FIPS 140-2 Level 2. In the links that are provided, you're able to read the entire standard, but trust me, it is a lengthy standard that has a bunch of different requirements inside of it. But basically, as a user, what our customers need to know about a Level 2 compliant chassis is that it gives a level of protection from physical targeting, the physical um, insecurities of the appliance. So, for example, one thing that the Safeguard appliance has is tamper-resistant tape to show that when there has been any tampering of the components, so that you as an administrator would know if any changes have been made. It also has things such as baffling and other opacity protection, so that if someone was to somehow take the appliance, that they wouldn't be able to inspect the appliance to see what components it uses to try to attack it physically. It also has certain locks and certain other locking mechanisms to protect it from having to have things such as the hard drive stolen and whatnot. Now, we recognize that this isn't foolproof, but this does give a layer of protection so that it can protect the appliance from any physical attacks that might occur. Another feature that the Safeguard appliance has is a locked BIOS. This BIOS is cryptographically locked, so that no end user or end customer can make changes to the BIOS and potentially install malware or other go-between software between the actual hardware and the OS. It also, if for some reason it happens to have some sort of attempt of cracking it or whatnot, then it does invalidate the TPM chip that's inside of it, which would destroy all the cryptographic keys, which control the at-rest encryption and other encryption forms inside of the appliance. On the subject of at-rest encryption, we do encrypt the drives, so that if for some reason the drives are to be taken out of the appliance, they could not be put in a different computer to be able to read the data off of it. And finally, we disable all peripheral devices such as USB ports, or have them not even manufactured, such as again, we talked about the video in, but other ports that might come on standard servers, as to decrease the attack vector. On the slide that's shown, this is an actual representation, or an actual picture of the back of Safeguard. And as you can see, there are only 5 ports. 3 of them are network ports. One is a configuration port, similar to like an iDRAC or ILO. And the final one is a serial port for break the glass instances where the application needs to be recovered. On the next slide, we do show you that. So in the right-hand side, you'll see a console, the black box with the text on it. That is a representation of that is an actual screenshot of our recovery console inside of Safeguard. This gives admins the ability to reset the appliance, power it off, factory reset it, pull support bundles, and so on and so forth. Since we've disabled all console access, there has to be a way of being able to recover the application if some problem was to arise. And this allows a Safeguard administrator to do that. So a couple of notes on the operating system and on the application is that we do use an embedded operating system, which means we also remove all unnecessary services that the operating system has. So things such as additional servers, whether there be web servers or file servers or whatnot, those services are removed. And we also firewall any other remaining services that the operating system may not let us remove, but that the end user cannot get access to. This decreases the threat surface of the appliance, of the application, and gives us one less way that an attacker can gain access to the system. The patching is controlled by one identity. The benefit that this is one, it allows us to monitor all patches for the third-party components that we use or the operating system and deliver those to you in a timely and safe manner. But it also allows us to control what those patches do. So as I mentioned previous, through our lab experience, we've noticed that patches that are put out by vendors will sometimes unharden a hardened configuration, make changes and add additional services. And each one of these patches that we apply, we thoroughly look at the changes that are made to the baseline system and make changes to our hardening procedures so that you can continue to have the level of hardening that you wish to have. As mentioned previously, we have no console access, so no users can log in. There's not even an actual video out on the appliance, and so there can be no video that the user can get to. Again, we use differing layers of encryption. We use at rest and in transit, and column level encryptions inside of the database so that there is a defense in depth and multiple layers if for one reason a layer was to fail. And finally, we do have the secure input and output of data. So as we bring data into the appliance, whether it's through a restore or some other means, we have layers of encryption that are used, and we also verify the integrity of that data before we run it. And likewise, when we output data, such as a backup, it is cryptographically signed and protected so that there is no way that any information could be taken out of a backup if it for some reason left the appliance or left the organization that had access to it. So these are just a couple of examples of ways that we harden and secure the privileged account appliance, so that you as an administrator or someone that is required to protect privileged accounts can sleep well at night. Just like Active Directory has been attacked multiple different ways as adversaries have found that it contains sensitive information, so too will they start attacking privileged account management solutions because of their ability and their way of holding all sensitive accounts and data in an organization. It's important that as you look at a vendor, you should look at the vendor's ability to protect their privileged account solution, so that as you continue to put the keys in the kingdom, they cannot be taken out by an attacker. And I'd like to thank you for this opportunity to share this with you, and look forward to seeing you on other One Identity webcasts that we will have. Thank you and have a great day.